What's really causing the friction in modern manufacturing? Is it shortages, supply chain chaos, or something deeper? Something invisible, yet embedded in how factories connect, or more often fail to? Well, my guest today is a man with oil in his boots, code in his bloodstream, and a mission to digitally reconnect the broken threads of factory communication. He's the founder and CEO of Pico MES. His name's Ryan. He's on a mission to solve a very specific yet widely ignored problem: the digital misalignment between OEMs and their suppliers. It's a conversation that moves beyond abstract transformation talk, and Ryan will draw on his hands-on experience from the factory floor, from General Motors to Tesla to running a motorcycle company, and show how manufacturing facilities are still running on decades-old practices, paper checklists, disconnected tools, and human memory. Meanwhile, OEMs are throwing around billion-dollar digital roadmaps, wondering why supply chain issues persist. And the truth, as my guest will explain today, is that you cannot fix a fragmented system with fragmented thinking. So if software can't talk across the chain, if the data doesn't flow upstream and downstream, you're not building a smart factory. You're actually patching a dumb one. So today we'll explore what the modern MES platform should actually do, and why most RFPs are destined to fail, and how smaller suppliers are often the most innovative, agile, and overlooked players in the entire equation. So how do we make real progress? Progress that's not measured in dashboards and PowerPoint presentations. And hopefully my guest has not only got the answers, but a few anecdotes, a few funny stories that will stay with you long after the episode finishes today. But enough from me. Let's get Ryan onto the podcast now. So thank you for joining me on the podcast today, Ryan. Can you tell everyone listening a little about who you are and what you do?
Oh, thanks for having me, Neil. I'm excited for the conversation today. But yeah, a little bit about me. I'll try to keep it small so I don't bore everybody to death. But I grew up in a small town in central Illinois. Kind of, it was a manufacturing town in the middle of a big agriculture area. So several automotive suppliers and different types of factories producing parts for a few different industries. But this is, I was born in 1980, so I grew up through the 80s and 90s before going to college and pursuing mechanical engineering, which I can't do the math for anymore. So I no longer consider myself an engineer. But 10 years with General Motors, 2 years with Tesla in the really early days, 2011, 12, and 13, bringing up that first factory into the supply chain. And then did some really neat engine controls for a couple of years on V8s and six cylinders that do cylinder deactivation before getting a chance to run a small motorcycle factory for 3.5 years. So kind of automotive focused. I love cars. I love making things, and it's just kind of work and passions have intertwined for a long time. So,
what a great story. And I'm curious, how did you go from that to the world of tech? And tell listeners a little bit more about how it led to the path that you're on now, what you're doing now, what the company you're with, and the specific problem that you set out to solve in this manufacturing space. Because it feels like you had the passion and a love for that manufacturing space, and that led to this. And it feels like there's a bit of a story there too, right?
Yeah, pure lack of other options that were acceptable. Well, in 2018, the company I was working for got in bed with another motorcycle manufacturer, some dirty dealings, and things kind of went south quickly on that. And it was time to go find another role. And honestly, after 20 years in the industry, it was, could I really stand going into another factory and trying to use not great software. I'll be gentle today on the language I choose, but to run that operation, and I just didn't have it in me to build another software set. We built one at the motorcycle company, and when we were at Tesla, was building its whole infrastructure, all because the choices were really not great that were out there. You had things designed for major enterprises that cost millions of dollars to get rolled out, and then took away all the flexibility from the shop floor teams. It just makes no sense to push them. So, living in San Francisco for I think 8 years at the time, something like that. 7 years, 8 years. It was like, oh, we'll just form a company and do this. It's the dumbest thing I've ever done. Don't do that. It's really terrible for your life balance. But it just couldn't live without a solution that tried to help people in the types of factories that were in my hometown, right? The supply base to the automotive industry and aerospace. So in 2019, we formed Pico MES and took the plunge and said, listen, we think, we don't know, but we think there's a better way to go about this using a fundamentals approach that we learned at Tesla. And we've been trying to break the system for six, almost, into our seventh year now, and haven't been able to. And it's really taken off and had some great success solving problems inside of factories. That's the goal. Yeah, lots of nuances in there.
Yeah, and I just love what you've done here, and also how you've took the problems that you've encountered in your previous roles and the lessons you've learned to pave the way for Pico MES. And you've also described a growing digital divide between OEMs and suppliers, which is something else that I suspect you've encountered throughout your career. So what does that misalignment typically look like on the factory floor, and why is it so damaging? Because I get the idea it's something you've experienced a lot.
Yeah. So one of my jobs at back at Tesla was to fly to whatever supplier was the most broken that risked the Fremont Tesla factory to not be able to produce Model S. We were trying to ramp Model S at the time. And so I would parachute into these different factories and do whatever we had to do to increase quality, increase output, whatever the bottleneck was, and then go to the next one. And it was just shocking to see, no matter what the parts were, it didn't matter if it was like a casting shop versus a machine shop versus a molder versus a harness. Like, the problems are all fundamentally the same thing when you look just below the surface. You have people and whether or not they can do standard work, right? Like, is there a definition at all, or is it just what you memorized from somebody else? Is it a binder on the shelf that nobody pays any attention to, or is there actually some amount of instruction and step by step? But then you also have the tool connection problems. So again, this kind of common theme of the solutions at the time, your best case scenario was like a moving PowerPoint or this fully automated line, which only works in certain scenarios. But if you could tie the tools, like a DC nut runner, a torque tool, a fancy cordless drill that shoots the same kind of style of rundown each time, if you could tie that to the person and the step they were on, holy crap, like, their anxiety level dropped because there was an integration now that ensured the right, like, they didn't miss a bolt and the right torque was applied. Printed a label automatically, didn't require, typing something into Excel to save a measurement. These little things with the tool side of the house amplified when they were tied to the people side of the house. And then that flows off all of this data that can allow continuous improvement to occur. And wait a second, the business now can actually be competitive, especially globally. You can pick up 20, 30%, sometimes more, depending on what that factory is operating like. I try not to say some people only gain 5%. Factories do actually operate quite well. And so other people will gain 50% in output because they were struggling a little bit. Well, imagine a world where you're in the automotive industry and you're going from supplier to supplier to supplier, and you see this over and over again. And you're like, well, wait a minute, you're printing a label here. These folks print labels. You're shooting bolts here. 6 factories down the road, they're shooting bolts inside of there. There's a lot of common solutions. And so I saw these lessons learned from my prior experience. And then this massive digital divide where the tools we had at General Motors and even at Tesla just didn't exist in the supply base. But it wasn't a technology problem. It was a way the technology is packaged and distributed problem. And so that's what we set out to solve was, all right, well, yeah, it takes 50 hours worth of work to integrate a torque tool the first time. But we could then spread that to any factory who ever wanted to use that again. And it takes time to set up, an interactive work instruction system that balances experienced operators with inexperienced operators. All the training data is right there, and it's out of the way of the experienced. Well, you solve that once, again, spread it across all of these factories. And that was the big dream. So it still is. And I think it's
Well,
really neat. We have over 200 families of tools we've integrated, right? Like families. So, we have one company that makes leak testers. There's got to be, I don't even know, 200 part numbers sitting behind there. There's companies that make electrical testers and, thousands of part numbers of their tools that all use the same protocols. Each one of those is just one family. So
well.
it's pretty rare we can't solve a problem when we bump into a factory. And that's what happens now when you set it up right from the beginning.
I love that. And another problem that we often hear about in this industry is supply chain problems. And what I try and do on this podcast every day is bust a few myths and misconceptions in every industry. And I think when anyone mentions supply chain problems, they automatically jump to shortages. That's kind of like programmed into us or pre-programmed into us. And one of the things that stood out to me is that you argue that the real risk lies in disconnected technologies rather than missing materials. So can you expand on that for me?
Well, the shortage is the culmination of the problem. That's the physical manifestation of like, crap, I don't have the part. I literally cannot build this thing anymore, or I've got to do a substitution and revalidation. But that happened weeks before in most systems, right? The thing that led to the shortage was caused by a lot of other issues farther upstream. And if you have a technology that allows connection across these factories, a common, way to communicate, you can get out ahead of these issues. The number of times in any of the automotive applications we had, was one of the main jobs is chasing potential issues that could shut down a factory, right? You think about how a Ford F-150, the most popular vehicle in the United States, is built. Right? There's thousands of parts that go into it. If you are missing one of them, you're done. If you're missing the handle that holds the tailgate on, your best case scenario is you can build a ton of trucks and put them out back until the handle shows up. And somebody's got to walk out there and put them in, but you can't ship without it. If you're missing a critical component, think about something that goes into the engine, right? You're not going to build up the vehicle and then add the engine later. You're stuck. So that's thousands of opportunities for something to go wrong to shut that line down. It's a giant risk mitigation problem. And yes, when the actual shortage occurs, that's the manifestation of the problem. But we just see a different world where, without sharing intellectual property or business case rights, if you have a digital infrastructure in these factories, you can use that data to get out ahead of these problems. And also, by the way, improve the efficiency of the entire supply chain as well. So we see a world where, instead of a shortage, if you had 3 suppliers that you were capable of ordering a part from, not all things can be multi-sourced, but there are some that can be, right? It takes the focus, and now you have less risk from that. But you still need a digital backbone, because if all 3 of them shipped you a part and one of them has a problem, if you can't, scan a barcode and understand where it came from, or somehow have lot traceability on them, well, that risk is now worse. Like, you've screwed it up even more. But with this kind of divide getting solved, I think you can actually get out ahead of things, and the shortages can be avoided. So to me, it's more about the infrastructure that led to it than it is about the lack of parts, in the modern world anyway.
So if we could manifest and throw into the universe a truly digital aligned supply chain, what would that look like to you? And also, what's stopping manufacturers from achieving it at the moment? Let's see if we can manifest, put it in the universe and bring it to life today. But what would it look like to you?
Are you familiar with how different kind of parts are built, and how many what they call tiers of suppliers there are?
No.
Yeah, so think about, like, what do I got lying around? Here though, use this tape measure, right? Just a cheap $4 tape measure I happen to have sitting here. Well, the outer case here is this formed plastic part. So somebody had to injection mold that, and then there's a little metal clip on this side of it that was bent and formed into this little piece. And then, the tape measure had to have a printed logo set on the thing. So there's probably a supplier that made the housing and a different supplier that made that clip, another one for the tape. And then they all come together into one facility that puts them together. So we call those tiers of suppliers that supply to each other before the finished good is completed. And then there's a whole supply chain and logistics world to get it to the end location. Well, the tier 2 would be so the bigger the number, the farther down the supply chain they go. If the injection molder is a tier 2 and the tier 1 is an assembler who puts together the whole spring assist thing, and they sell it off to somebody who bundles it with a couple other tools and sells it off as a kit, right? The key to that is the finished good at the other end of it. If it could see, hey, how many parts are in process right now at the tier 1? And if the tier 1 could see, how many parts have we molded, or do we have the pellets to be able to mold parts at the tier 2? What's their capacity look like? Are they going to be available to us, or do we need to order farther in advance? When it ships, are they shipping to other places that are near us? When they have scrap, whenever you mold a part, there's a little tree on the end of it. You got to cut that off. Most companies regrind it, throw it back in. But in the machining world, you make chips. Well, they don't have a smelter there. So, what do you do with that material? You throw it into raw recycling. Well, if you knew the exact alloy, could you take it and recycle it cheaper, better, stronger without having to realloy it? All of that can happen if data is shared. And none of it has to be how much time it took you to produce it. You don't have to share business case related items. But that's how we see a digital supply chain is it's not just like, hey, I ordered these, when are you going to ship it to me? That seems to be the kind of normal mode. It's here's the critical dimension of the part so we know it's good. Tell me when you consumed this material so I believe that your next order is real and you're not going to cancel it on me because you don't have some stockpile occurring inside of your facility. There's all kinds of what I call little point solutions that can, each one of them gain 0.5%, 1%, these little business efficiency gains that stack up to huge changes. And so we see a connected supply chain as being able to move data across it, negotiated by the parties, what different information is shareable and what's not. But today, what are you going to move an Excel sheet? Send a piece of paper back and forth, right? If you don't have that backbone, it's not possible to do any of this sharing. And so what we've been doing quietly in the background is building this. So we can deploy into a tier 4 injection molding shop, for example, and monitor the press and the temperatures and certain critical to quality dimensions or whatever it might be. And then when it gets shipped up to a company that's going to paint it or make a higher level assembly, that information can be compiled onto the end of the data string. And as it goes up and up and up, by the time it gets to the automotive OEM, for example, you could see all of the critical dimensions just by scanning a barcode. Beep. Oh, pops right up on the screen. Ding, 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 ding. Oh, I'm curious about this dimension right here. And then every other player, the logistics person could say, how much inventory do we have if we need to make a change all the way through the supply chain? All of these different views are enabled by having a data model that allows this data to be compiled. So anyway, it's kind of funny. It's a big high level issue, but what it comes down to? It's right back to those same problems. If you want to be able to collect the data, you've got to have consistent ways of building something. So there's your standard work and your people guidance. And most of the interesting data is measured. So you want to be able to connect into the tools to get it. And then you need to be able to organize it in a way that it can be shared easily. It's really simple fundamentals, but are really, really difficult to do if you don't build for it from the beginning. I think we're in the world where a ton of cell phone apps exist, but there really isn't an iPhone yet. That operating system doesn't exist yet.
And I suspect you've actually cursed me without realizing it, because every time somebody's going to pull out a $4 tape measure in front of me, I'm going to feel compelled to repeat that story verbatim now, because it brought it to life beautifully, man. And you've also said that smaller suppliers are often more agile with real-world digital solutions. So What lessons can OEMs learn from these smaller teams, do you think?
One of my philosophies, it's a little counter to others, is that often some of the biggest factories run at the highest efficiency. And I mean as far as like output per shift relative to the best possible output per shift, not the economy of scale for material. But they typically are way more complicated and shouldn't be the highest efficiency. If you make the same widget day in and day out, I bet you're really effing good at it, right? Like you probably can really dial that process in, and you don't have all the rest of that complexity. So smaller facilities have the ability to focus. The other side of them is they can take a little bit more risk in certain ways, right? They're not going to blow up their business case, but they have flexibility. There's probably the owner is intimately involved in what happens at a given station, so they have the ability to dig in a little bit more. And so these OEMs, if you're paying attention to what's happening at the smaller factories, you will often learn tips and tricks that you can apply in your own factory, or you could actually even drive direct experimentation into someone's factory that you could use and take to larger amounts. We often see it as tool integrations, right? The smaller factories, if you look across the supply chain, there's thousands of them for every large factory. So each one might only bring in one new tool that they're using in their factory. But what it did is it compiles dozens of new opportunities for the big OEM to take advantage of that integration without having to build it themselves. I see it a lot more in like little things. We had a customer use just a really clever switch. They called it a hip switch. But so if you're in a factory and you got like your hands are covered, you're building things, right? You're using your hands, and you got a screen up here that is just kind of clicking along in the background. Every once in a while, you need to hit a switch to acknowledge something, maybe a quality check, like, did this pass? Yes. So you could either use a mouse and like click on that button. It's kind of annoying, takes some time. Your hands are covered in crap, right? You got a touch screen. Well, you don't want to wipe it all over the touch screen. So they used the traditional solution would be a foot switch, and you can like click it with your foot. But if you're moving around on a bench and you're not quite finding it, then you got to look down, find it, click the switch. I thought it was really clever company. They put just a big red button on the edge of the desk, and the operator smacks his hip into it, just like clicks it. It's not a heavy force or anything. And I was like, oh, that's really clever. Mentioned it to a semi-truck manufacturer who now has them all over their stations.
Wow.
It's just these little things that go for quality of life improvement, or produce a small gain in output per shift, or whatever it might be. If you only are looking in your four walls, you are only as smart as that set of information you've got to learn from. If you can look across thousands of buildings for clever things like that, then the entire system can gain. And that's honestly what we do more than anything else at Pico. So we take, this is a really good idea we saw in one place. We strip out any intellectual property. We don't want any competitive advantage loss or anything. But anyone else that's using that tool, hey, did you ever think about mounting that thing on the side of the desk there so you could pop it with your hip? Just that's a small example, but multiply that by thousands of them.
Yeah. Oh,
so
wow,
that's just how OEMs can learn from smaller factories through millions of other ways to do it too.
Yeah, classic marginal gain or continual improvement there. I love it. Well, let's talk about implementation for a moment. What should manufacturers be looking for in a modern MES platform, especially if they want to bridge the gap without that lengthy, costly IT overhaul that every organization dreads? Any tips or advice on there, what they should be looking for in an MES platform?
We were talking about artificial intelligence before we started today, ChatGPT specifically. So I was talking to a very large manufacturer. This is a Fortune 100 company, and they're doing a rollout across their facilities of their MES solution between now and 2030. How relevant do you think that rollout, designed in the last 2 years, is going to be in 2030, given the move of technology? So I think it's admirable that someone's trying to get a base infrastructure across all of their factories. But I think it's foolish if you think that's going to be the solution that you're going to get to use for the next 5 years. So the key to these implementations is flexibility, in my opinion. Gone are the days of a monolithic solution that's going to, you think SAP is going to solve world hunger for you. Just let me know your company name so I can get the short selling going on the other side of it. I'm just going to watch you implode. If you think you can run without an infrastructure, though, you're just as silly. So I think the key to this is, like everything in this world, moderation. It is a very good idea to have a strong infrastructure in SAP or Oracle, or pick your ERP of choice, is a good idea to have in the background. And those are going to take, months, if not years, to roll out. But it can't be the only solution. So the key to this modern implementation is bolting on things that work with your core, that can be deployed rapidly, that have the opportunity to change over time, that are flexible. And so it's not as hard as it used to be, because now everybody's built for these, we call them APIs, but the back and forth. But you have to think a lot more about, okay, how is this going to change over time? What happens when, artificial intelligence becomes a key way for us to view our data, where you're using a chat bot to answer questions instead of having to build what's called a SQL query in your own dashboard. Are you built for that? Do you have a common data infrastructure that can work with that? And then the other side of it is, are you building something that your shop floor is going to hate? Because it's not flexible. It requires some PDF generated work instruction that takes hours to edit. If they want to add a new tool, is it 5 minutes or 5 weeks to be able to collect data from it, or error proof a process with it? And so I think the modern world now looks like much, much more rapid deployments of technology that you can validate in a particular application and then use it all over. And then you find the next application and you use it all over for that. And if it takes 7 software sets to get that in place, the other side of it for the buyer is that's not your problem to integrate. If that solution comes through and is like, well, it's going to cost you $100,000 for us to connect into that system, like, that's your problem. Your software isn't flexible enough to connect into the others. Like, that should be pushed to the vendor, which is a weird thing to say as a software vendor. But so anyway, for modern rollouts, to me, it should be like we roll out across factories in weeks. We did 200 stations in 3 months. 200 fully integrated torque tools, PLC connections, scanners, printers, full traceability, in a factory in Tennessee. Like, that's how fast things should be. If you need to go across your entire organization, you should be able to do 5 to 10 of these in parallel at the same speed. Otherwise, you're going to get left behind. The world moves fast.
It really does. And listening to you today, you've got a real gift for bringing things to life through stories, whether it be a $4 tape measure or a red button that you could switch with your hip, And I'm curious, to further bring to life everything we're talking about here, if you look at all the work that you've done, especially on the factory floor, is there a story or maybe 2 stories from suppliers that you've worked with who've successfully adopted factory floor technology to better sync with their OEMs? Because there is a certain amount of fear on the factory floor around any new technology, and you always have to tick that "what's in it for me" box. But are there any stories that you can share around that?
Yeah, we have a handful of them that are public. A lot of factories are pretty conservative about what they'll talk about, but in general, there's some interesting ones in there where you've got companies that have like a culture shift occurring in the middle of it, right? You got the classic, like, I don't want to interact with technology operator who says, leave me alone and let me do my thing, versus maybe someone who was working at a fast food restaurant the week before and really needs a lot more guidance because they've never installed a fastener before or made connections across things like that. So, an example, one of them we talk about from time to time is this company Moride. Company you probably never heard of unless you're in that industry, but they supply into the RV industry, for example, and it's they do effectively mini automotive supply structures. For them, a key is high mix they make thousands of different, what they call SKUs or part numbers of components across all kinds of different technologies. But not only do they need to be able to guide those workers, but they need them to then produce them efficiently, because that's a pretty cutthroat market. Right? The RV industry is notorious for boom and bust, and you need to be profitable in there as you're ebbing and flowing. So they rolled out hundreds of different processes in their flex assembly areas so that their workers could build a TV stand and then immediately follow it up by like the stairs used to get into the RV, and then something completely different, all without skipping a beat, right? That ability to move from one thing to the next because there's guidance right there for them on the screen. If we have an automotive supplier, really neat minority-owned company called HJI. They're in Kentucky. They supply into like Ford and or Toyota, places like that. But their ability to win future business is tied to, like the OEM appreciates smaller factories because they're more nimble and can react quickly, but they can't tolerate mistakes. Right? You're not going to shut down that truck plant. That's like a huge no-no. 3,000 people twiddling their thumbs is a big deal. So you have to be able to show that you have full traceability, that you have error proofing, you have control over your processes. You don't think you know exactly how you built something. And they were able to deploy Pico rapidly to be able to do that. And I've won additional business because of it. Right? Remember that whole, what can big OEMs learn from smaller suppliers? That also goes the other way too, where as they've learned from them, they feed more business into them because there's more confidence on the other side. I mean, I can't imagine sourcing a part and walking into a factory and be like, show me your clipboard that you're recording that data on. Okay, who's the poor bastard that then has to go type that into Excel? And then how long does it take before you could send it to me to say that it's good? Yeah, that sounds great. Here's a contract. Like no one, like that's not going to happen anymore. They expect you to be able to have that all digitally tied together back to the serial number of the part. And they say, hey, we just had this one component that didn't fit on the line. Did you make one bad one or did you make 5,000 bad ones? If you can't prove to me that it was just that one off, it was at the edge of a tolerance and maybe we all thought it was okay and it wasn't quite, and we need to adjust that tolerance, and that this just doesn't play that way anymore. So yeah, it's an interesting world. But yes, there's a lot of these little kind of neat factory examples that we get to see from time to time. One of my proudest stats, by the way, our smallest factory, 6-person wire harness shop. Critical component for certain supply chains, right? If the wire harness is bad, nothing works. Our largest factory, 1,800 people per shift building vehicles. And they use the exact same software. That's what modularity looks like. And that's what I mean by take the little chunk that works for the supplier, but you can leverage it at the big one. Well, it goes the other direction too. Everything learned at the big factory can be leveraged by that little supplier.
Wow. And I've got to ask, because I always try and leave everyone listening with a valuable takeaway. So if we have manufacturers listening, people working in this space, both big and small, or could be located anywhere in the world, what advice would you have for them that when they know they need to digitize, but just aren't sure where to start? Because I think a lot of people now and a lot of enterprises in any industry, they know they need to change. They know that they need to adopt technology, but not knowing where to start, that is the first stumbling block. So any advice around that?
We see a couple of things that come in, and I'll warn against one and encourage the other. We see these global, like we call them requests for proposals or an RFP, a request for quote, RFQ. But it'll often say, this is my wish list of everything I could ever want in the next 5 years. But anytime we see that, it's usually a team that just either already has a solution and it's just they already know what they want and they just wrote the RFP for that. Or they honestly are going to struggle, because when you write a proposal like that, it means you don't have any priorities. You don't necessarily understand the key things that can really move the business in the short term to build adoption, build momentum, and keep going. And what actually seems to work better from just the dozens of factories we've rolled out is focusing on usually 2 paths. One, is this robust enough to do what we need it to do? So testing it in use every day, over and over and over again in your environment to make sure that it's correct. And then in parallel with that, saying, what are the various solutions that we need that we could then copy and paste throughout our factory or factories, right? Where's the multipliers? Where's the things that can really help on the business case side of the house? And so often it's like, hey, we shoot a lot of bolts. How well do these things work with DC nut runners? We need full traceability because we make a medical device, or we make aerospace components that are certified, or whatever that might be. Can we not only collect all the data, but then have it organized in a very easy to use manner? Can we automate it all the way through? So here's the report for our customers on the other side. Whatever those solutions are, that's just that kind of business value of technology. You run that in parallel, and then you just fix the solution, use it, fix it, use it, fix it, use it. And that tends to go significantly faster and significantly higher value than writing my unicorn RFP and hoping and praying that somewhere in there are all the things that we could need over time. There's nothing wrong with having that plan, but you got to have a focused rollout on the other side. So that's my advice. Is think it through. Do the math. The business value math is as important as the shiny object of the technology on the other side.
Completely agree with you there. And of course, there's also a real pressure on each and every one of us to be in this state of continuous learning, to keep up to speed with the pace of technological change. Now, you're in a privileged position of leading the way here. You must feel that pressure more than most. So where or how do you self-educate? How do you keep up the pace?
Well, for industry stuff, we have the neatest job of them all. I call it industrial tourism. But if you think about the companies we support, I get to learn from each one of them over time personally, right? A lot of it's protected under IP rights, so it just stays there. But you get to see really neat things. I was chuckling earlier. How I learn now is very different than 25, 30 years ago, because of the way we can access information. So I tend to veg out in front of YouTube and watch all these educational videos of how people build hot rods or, weld and fabricate, because that's what I'm into. But all of those series also get into modern machine shop, walks through machine shops and shows, how these smaller shops are producing parts all day long. And I get to learn through those video series. Used to be Discovery Channel, right? And History Channel for all those things. But I tend to learn through watching experiences and then trying to replicate those experiences myself. And then obviously voraciously reader, lots of articles and things. I'm super interested to see what learning does as ChatGPT becomes more a part of my daily routine as opposed to my weekly experiment, in seeing how much I learn through hallucination versus reality. But I think you can find information, and the key is, it's about spending time. I bet I spend 3 hours a day learning something in some form or another.
And we started the podcast talking about your origin story, what put you on this path, where those passions came from. As we now come full circle at the end of the show, I'm going to ask you to maybe look back at your career now, because I suspect that, well, I would say none of us are able to achieve any degree of success without a little help along the way. Very often we encounter people on that journey that see something in us, invest a little time in us, and help us get us where we are today. Those people are very often blissfully unaware on the scale of the impact that they've had. But who would that person or people be for you? Maybe we'll give them a little shout out today.
I mean, my heroes have always been my parents. I've had, a wonderful family upbringing where my mom and my dad went to college on the GI Bill coming out of Vietnam. My mom went to college with 2 children after he was in the workforce to pay for the whole thing. And they kind of started at the very low end and accelerated especially my mom dramatically through their careers. So it's been really awesome to have that kind of experience to follow along with. The most influential thing, so when I was 30 years old, or just under there, it's probably late 20s, this might shock you, I was a little bit of an asshole at the time. Quite a bit of yes, when I was at General Motors, and I liked to pipe off a little too much. Who's now one of my best friends, was my boss at the time, and literally in a meeting with other people had the courage to yell at me openly about when I was being an ass. And nobody had ever done that. because most people just don't care. You just write off the person that you don't like and did that. But he had the gall of saying, like, hey, this is really your issue. You need to solve this. Like you've had more opportunities, and it registered with me, and it literally changed the course of my career dramatically. It's kind of rare. I think people can point to one person who did one thing like that. But yeah, guy's name's Mark Stilo. He's the head of GM Racing now. But he literally piped off at me and changed my whole life. So, Mark, I don't know why you'd be listening to this, but if you did, thanks, buddy.
Wow, what an incredible story. And I fully expect that Mark is GM Racing now, blissfully unaware on the scale of the impact that he's had on your life by just calling you out on your shit, so to speak, and reining you in a little bit. So a big shout out to Mark. We need to get Mark to listen to this, man.
Yeah, he travels enough for his current job. But I think, there's the book that was written, Radical Candor, and others, but I do think there's something about having the courage to actually help someone and really caring enough to do it. And it's pretty neat when it happens. I don't know that I'm the best at it, frankly, on the other side, but I aspire to be, because of the impact it had for me. So.
Well, I think that is a perfect moment to end our conversation. But before I do let you go, anyone listening wanting to find out more about Pico MES, how the problems that you solve in the manufacturing space, how you might be able to help them, or just start a conversation, what's the best starting point for everything?
Yeah, following us on LinkedIn is a great way to keep up over time because we do a lot of posting there. The website's obviously a great place for more information, digging a little deeper, and don't hesitate to reach out. Connect with us through all the various medias, LinkedIn, X.
I'll have links to everything to make it easier for people to find you. And we covered a lot there, from digital misalignment between OEM factories and their suppliers, how this digital divide in the supply chain risks costly delays and errors on the assembly line. But onboarding factory floor tech that communicates directly between these two parties can serve as a solution. And even if you get a little bit out of hand, Ryan, we can rein you in a little bit as well. But thank you for joining me today.
Yell at me when you need to. Please do.
For me, this wasn't just a conversation about manufacturing. It was a masterclass in making technology practical. And what I take away from Ryan's insights is that real digital divide in manufacturing isn't about access to tools or capital. It's actually connection. OEMs are scaling billion-dollar ERP systems while their suppliers are wrestling with Excel sheets and outdated machinery. And it's that disconnect that leads to delays, traceability gaps, and preventable shortages. But I think Ryan's vision is refreshingly grounded rather than promising a one-size-fits-all platform. They're solving real problems on the factory floor, problems that Ryan has lived through and refused to ignore and done something about it. So if you're a manufacturer, big or small, here's a takeaway. Start small, solve something real, and scale from there. Fix the thing that's holding up your line, then fix the next one. And for OEMs listening, there's a lot to learn from your smallest suppliers. Sometimes the best ideas don't come from your global consultancy. They can come from a hip switch on a crowded workbench. But if you've got a story about how your factory is solving digital pain points, or maybe you can share where you've hit a wall, I want to hear from you. What's your take? Are we over-engineering transformation? What's the smartest digital fix that you've seen on the factory floor? And do you have any funny stories you can share with me? Drop me an email, techblogwriter@outlook.com, LinkedIn, X, Instagram, TikTok, just at Neil C. Hughes. So let me know your thoughts, and I'll return again tomorrow with another guest. But thank you for listening as always, and I'll speak with you all then. Bye for now.